This is the carbon nitride nano sheet. um, I just made this unit cell 3 by 3. Actually we can make 1 by 1, but it becomes very small. um, to make it more convenient to visualize, I made it 3 by 3. So this is the sheet that I'm going to put the hydrogen on top of this to check whether hydrogen is binding with this sheet or not. Now, in order to do that, there are a lot of calculations and simulations that we'll have to do. This is just the input file that I'm preparing, and then as per my output, that hydrogen is not binding with the carbon nitride or this sheet. I'll just show you the view. This is here we have x, and b is y, and c is z axis. Okay, we have x, y, and z. It should be the 3D view, but in order to get the more space, now you will understand, like if you're interested, you can really go into why we are going into the surface area rather than the volume. So we are making this one into nanometrial and making it bigger space, whereby we can accommodate more number of hydrogen molecules. So just with the z view or the top view, it looks like this. And then, since this is just a sheet, uh, from the side view you will see just vertical line, which is like from the y-axis view. And then if you just take from the x-axis, you will see again the horizontal line. But our interest is in this from the top view. And then for that, I applied the hydrogen molecule and then run the simulation, but hydrogen is not binding with the carbon nitride. So I need this sheet by any means. Of course, there will be other materials to store the hydrogen, but this one is more. I mean, I find this more advantage. Of course, researchers have their own justifications why they are selecting the sheet. So through through the literature and other, the observations, like I find this sheet more advantageous. And now, in order to make it bind with the hydrogen, so I just put that's the same sheet that we have here. This is the sheet actually, nanometrial sheet. Okay, so I just put the metal atoms. Okay, again, there's the reason why we are applying the metal atoms here. Now this is all about the characteristics of the elements, like the electronegativity and electropositivity. So when it comes to the carbon nitride and the hydrogen here, of course here hydrogen is not shown. Okay, that brown one is called the carbon, and this gray one is called the nitrogen. um, I've not shown the hydrogen here because when I run the simulation, it's not binding. There is, not binding, where you should understand as like hydrogen is not sticking on the, not bonding with this carbon nitrate sheet. The reason is carbon nitrate is chemically stable and it is of higher electronegativity. Nitrogen is also have higher electronegativity, and then carbon also have higher electronegativity. And then when we put the hydrogen, I'm not talking about the single element, atom. I'm talking about the hydrogen molecule H2. So hydrogen is also electronegative. And now hydrogen is like, hydrogen is already, H2 is already bonded with H and H, which means they share non-polar covalent bond. So which means now hydrogen molecule itself is stable. C3N2 is also stable. So there's no, binding force between hydrogen and this carbon nitrate sheet. Therefore, to make hydrogen bind with this sheet, we are adding the metal sheets, metal atoms. Now I will just show you the actually research interest should be in particular field here. It should be one minute. Okay, it's all about geometry. Okay, my research focus is only in this unit cell. Okay, not like a whole this big chunk. Actually we can do like that, it's just a waste of time. We Others are just the repetitions. Like if we just focus on this two here, I mean this one unit here, then the rest are just the repetitions. That's why I'm just focusing on like this. And then I added four numbers of metal atoms. This is potassium. um, Now in order to reach into this four numbers of metal atoms here, I did again numerous simulations. First I added one atom, check the binding energy, and if it is within, I mean if that the result is good, then I again added more, and I have added another like metal atom, and then I brought it till four. Actually if we add more, this sheet can accommodate more numbers of metal atoms. But we should also check the distance between potassium and potassium. When that potassium exists in a bulk, there should be some minimum distance like 4.57 angstrom, that bond length. So we have to maintain this kind of distance between this. So that's because of that reason I have limited my metal atoms in the unit cell as four number of atom. And then after that, then I checked with the hydrogen. Again I will show you the unit cell, not the bulk. One here, one, and then let's see. So this is how it looks like. Actually in the first case I tried to place the hydrogen on top of this, I mean top of the metal atoms, but somehow I have observed that if you just check the views here, um, my expectation is like this metal atoms should be also in the single layer, but instead of doing that there's some kind of displace away from the sheet. Of course that's there because of the electronegativity and electropositivity of the elements here. They, I mean the metal atoms are bonded with the carbon sheet. And in my like before I run the simulation, I have just placed all the metal atoms of the same height. I mean the z-axis is same for all the I mean the atoms here. But when I run the simulation and hit the this whole, I mean system with the temperature up to 300 Kelvin, I see there's some kind of change in the position. So this is like a stable state, I can say that. Now on top of that I can also place the hydrogen same as this atom here. Here I have placed on top of the potassium atom, here also on top of potassium atom, and here also I can place on top, and here also on top. But because like these two are below the sheet here, if I place just on top of this, I find there could be some kind of interactions between hydrogen and the what's it, the sheet. Therefore I just tried to place on, I mean the under the this potassium elements. And then now with this again I will have to generate the file, which I have already generated. Yeah, this is the file I have. Yeah, this is the file that I will be using in the simulation. So this is just the latest parameters of the system that I'm using, and these are the elements information. For example, I'm using the carbon nitrate as a carbon nitrate. This is the main sheet, and the number of atoms that I have is 18 for the carbon, 12 for the nitrogen, and for the potassium I have added 4 atoms. And then when it comes to the hydrogen, you will see 4 sets, 1 2 3 4, but total number of hydrogen is 4. That's why it's becoming 4 here, I mean 8 here. So these are the Cartesian coordinates x, y, and z, and then we will have to give the location of position of the each atoms. And then this one I'm going to, okay, I'm going to uh, okay, I don't know, yeah, I think this will be visible. And then I will just set this I mean the file which I have shown in the text file I've given there, so I will just show you. um, so see, now this that file which is generated from the model is now converted into this text, and then I'm going to run this. So after running this, then you will get some kind of result. Actually this is I'm running this file, but it's not yet done. Ls minus lt here, just to check. See, it's still running. Today is 11th July and then 11:57. My time is also 11:57 right now. So this file is still running, so I don't have a result for this, so I'll have to wait. And it takes almost like if the system is good, it takes, I mean, the simulation converges before the time, but sometimes it takes 2 days. And then if result is not good, again I'll have to rerun this. But while running I mean, while I submit the rerun, I mean submit again, I don't have to do it from the beginning. I'll just have to copy some kind of the file, output file, which I'll get it from here. Again, this file I'll make it as the input file, and then I'll have to run. So this is just brief about the research that I'm doing. At the end, we will see, like in the I mean in the carbon nitrate, by adding the metal to pens, how many amount of hydrogen can be stored. So this kind of research that I'm doing. If you're interested, and then if you're interested in the same field, let's always discuss. And yeah, that's it for now.